This is the relay frame that comes out of the IBM Model 29 Keypunch. It is a significant improvement over the IBM Model 26 Keypunch in that it doesn't have any vacuum tubes at all. Instead, it's replaced it with some relays, a couple of resistors, a couple of diodes, and these 2 SMS cards. And that's it. And it really reduced the time to do a lot of maintenance and testing, and also made them more reliable because you weren't now dealing with vacuum tubes as part of the process. There's no vacuum tubes in this Keypunch here at all. The relays here are actually all pluggable, and of course of IBM's design. These are called wire contact relays. There's little tiny fine wires that are tensioned and go through here to your normally open and normally closed armatures on the back. And of course you have contacts here for not one, but there's 2 coils in many of these relays. These allow for the ability to pick a relay and also to pick and hold a relay without interfering with each other's circuits. And they're also keyed with these 2 stainless steel rods, but they just plug back in here. We also have these boards right here. So these are SMS cards. The proper, the full name for them eludes me at the moment here. This was kind of IBM's building block at the time for their computers, their peripherals, pretty much everything. So you have 2 rows of axial holes here for axial components, resistors and diodes on here. And they're also, interestingly, the same width, so you can also add larger components, such as this capacitor here. And then we have these triangular 3-hole sections here where you could drop in transistors. What IBM was doing here to keep costs down is that they were standardizing the physical board and edge connector layout of the SMS card so that they only had to design the board once, and then they could remap the circuits however they pleased for each different one. So this one here only has etching for these particular components. Everything else on here is completely empty. And it has a nice set of gold contacts here on the bottom. These boards here are used for arc suppression. This is all 48 volt or 40... I'm going to say 48 volt. And so this is the low voltage DC stuff. It's really quite harmless in terms of having to work on it when it's active. All these open spots over here, they do look like you can fit SMS cards over there, and they do fit. But again, this is just IBM reusing the SMS card design. These are where all the connections for the wiring harnesses, both for the keyboard and for the machine itself, plug in. And there is no printed circuit boards beyond this in this frame here at all. In fact, if I flip it over, it really does dominate my desk. There we go. When I flip it over, it's really difficult to see. I got no way to zoom this out, so you're just going to have to deal with me here, but you get the idea. This is all point-to-point wiring. Each and every single wire here plugs into a socket on the back of all these connectors. And in fact, over here even, they do have cables that terminate into little compression fit connectors, but it's also wire wrapped over here as well. So this could be wired and tailored to as seen fit by the OEM and vendor, and there's plenty of room here for expansion. And there were other options available which added even more relays and even more SMS cards for things such as I think it's zero write addressing, or it's a zero write option. Basically adds a set of zeros following each card count. We do have 2 resistors here. I have tested those, and those are fine. Other than that, besides being dirty, the relays we'll deal with at some other point, there wasn't too much damage. One wire was broken right here, and as you can see, I've actually gone and I've repaired it and put some heat shrink tube over it. It's clear stuff. But I had 2 wires that had pulled themselves out, and I can barely reach them on here. Can I just use this as a... I sure can. Okay. So, ignore the flag here for a moment. These are the little tiny crimped ends on them, and the idea is that these pop into any of the many, many hundreds of holes in all of these relay blocks. The blue wires here are actually jumper cables, so you can go from one to the other, but the black cables here are of a particular cut length and go off to other relays on the board, or they terminate again over where the SMS cards and the connections to the main harness are. And when I received this, 2 wires had been unplugged. That was going to cause me problems because now I had to figure out where the other side of these wires were. And I had another problem on my hands here. I do have access to the documentation for these key punches. The wiring diagrams are available online on BitSavers. The power supply is really as simple as it shows here. But these are for the Model B. And as a result, I was running into issues where the Model B doesn't have exactly the same wiring as the Model C. In fact, quickly switching back over here, this one here says 321A. So you're probably wondering what the heck 321A means. Going back over here, there is at least one use for this sheet, and that's this page right here. I'm just going to zoom in on it. Can I zoom in any further? Sure can. Thank you. There we go. This is called terminal block number 32. That's where all of those components, the diodes, the resistors, and all that were kind of plugged into. It's not like a typical relay connector. It actually allows the components to be plugged in, again, with like these little plugs and sockets that are crimped onto them, and then you can connect through. So 321A refers to terminal block number 32, location 1, hole A. And we're looking at this from the component side. Okay, so how on earth did I find that? Well, that was easy enough. So I'm going to turn my multimeter on here. I'm going to put one lead onto there. I'm going to put one lead onto there and not fail at that. And then simply with continuity on, I would just kind of rake over every single contact and pin inside of this. And eventually I came to find that 321A, hiding down over here, was my solution. That was the other side of this, and I couldn't find another side, so that was definitely point-to-point with no junctions or splices in between. Okay, so now I know 321A is one side. What is the other? Well, like I said, we can't really tell with the Model B schematics because it's just not wired the same. In fact, actually, I think this was it right here even. Yeah, 32.3. So, no. 32.2, 32.1's hiding here somewhere. Anyways, the point I'm trying to get here is that when I looked it up through this, and I did a fair bit of digging, it wasn't the same. The wiring, like it was going to relays that just did not exist on here. All of these relays are numbered and labeled, and the relays that this was calling to did not exist. So I had a problem. Now, enter Curious Mark again. Because at the beginning of his restoration, he pointed out he has the documentation for these. And he has the wiring diagrams. That was the big one. Nobody else had a digital copy of them. So I emailed him. I explained my situation. I explained the progress on this Keypunch. And asked, would you be able at some time to scan that documentation in so I can determine where these wires go in the diagrams, because the Model B and Model A diagrams don't have it at all. And he said, sure, I will try. And I told him, don't rush it, please. Like, I honestly have a bunch of time on this. And a week later, he comes in with these. He comes in with a complete set of wiring diagrams. He's gone through it all. He's gotten it for me. Curious Mark, thank you very much for helping me out here. This is exactly what I need. Okay, so again, 32.1A. So we know that that's there. We know we only have one wire, and it has to plug in somewhere. Going back over to our schematic here, I'm going to go big here. I know where this is already, so I'm going to page 11. I'm going to zoom in a bit here, and we are looking for 32.1A. There's TB32.1, FDE, TB32.1, BCA. So there's our A line right there. So we'll follow that, and that goes to the normally open contact on relay 17, position 1. So here's another catch on you for that one there. Let's just quickly go back over to here. Where was it? There they are. When you see the terminal block here, it lists component side. So when you're looking at the components sticking out, like I said. But when you look at the wire contact relay sockets, you're looking at the wiring side. That is the side that all the wires are plugging into. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So opposite way around, mirror opposite. So we know for a fact now, going back, that it'll be 17.1 on our normally open contact. And what is our normally open contact on this? Well, let's quickly take a look. Normally open, so it's going to be in the 1, 1, 2, 3, 4, and 5 or 6 is going to be what we need. So we'll do... Alright. This is really awkward. Now you see how these are all numbered? So we're looking for 5 or 6, I believe. One, 2, 3, 4, 5 or 6. Okay, let's see what's going on here. And if we go back onto the documentation again, should go to 17.1, normally open. Actually, hold on a second. Something's funny here. Ah, it branches off. Okay, we should be looking at... It should go to both 17.1. It looks like a normally... Oh, it's a common contact. Hold on. I see what's going on here. So, 17.1 common, 17.5 normally open. So at some point here on the relay, there's a jumper, which goes 17.1 to 17.5. And again, we'll go back at this. So our common is going to be pretty much right up here in the corner, any of the first 2 pins. And we're looking for 5 normally open, should be down over here. Okay, that's easy enough to find. Let's see here, desk cam. So I'll do 17. I'm going to pop this into our hole right up here. And that technically means that this one's good, but now we need to verify that this is really not designed to be worked on with an overhead camera. There. So now we know we have, it should be in the right spot, but if it goes to point 17.5, normally open, we know for absolute certain that both the schematics are correct, and we have it plugged into the right place because the wires are going to the right spots. Now, I do see that there is immediately below it a blue jumper, which disappears somewhere into here. It's a mess. So what we're going to do is I will take our continuity meter, again connect on to 32.1, excuse me. I will flip this around, And hope that doesn't fall off. There we go. So here's our relay 17. I'm going to pop that off. There we go. And we mentioned before, whoops, there we go. We mentioned before, now it should be backwards. So 1, 2, 3, 4, 5, 6. Oh, what was that? Oh, duh. I'm sorry. What was I saying? No, 1, 2, 3, 4, 5, 6, which means normally closed, normally open, 1, 2, 3, 4, 5. Okay, so yes, that is the correct spot for that wire. We can mark that one down. There we go. All right, so that just leaves us with one more wire. And we have here, on the other side of this, I determined it was 26.8C, which was a normally closed contact. So about half an hour later, I figured this one out. It was actually a little bit more complicated than I thought it was going to be. And if we go over to the schematic again, I did finally manage to find our 26.8 normally closed. It's in the interpret circuit. So yeah, the Model B schematics would definitely not have helped here. So there it is. It goes to connection 50 on section 5B. So here's 5A, B. So it also goes to 2610 normally closed, and from 26, 26, sorry, it's late. From 26.9 normally closed to 2610 common, and I verified those are correct. It then goes to connection 53, section 8A, which should be 48 volts. See, there's our 8, there's our A, there we go. At which point there, it should go straight into 48 volts. Or over to our punch interpret switch, which, as I've mentioned before, we don't have the correct keyboard. So this is missing, and this is also important because now I know how that switch functions in this circuit. But anyways, this came up to be a bit of a confusing case. There was nothing specifically saying 26.8 went anywhere else, and I had already determined through MS Paint 26.8, there we go, 26.9, 26.10, and we have our 48 volt line. But what was this extra wire? Well, I think the easiest thing to do here was to immediately see what else on 48 volts beeps continuity to any of these three locations. And it should be associated with our wire at the same time. The way to find that is kind of the same on both. We're going to use Curious Marks diagrams here. Can I go up? There we go. There we go. I'm going to zoom back in again. So this is the wiring diagrams for the 48 volt circuitry. I think it's chained. It's all series chained. It might also just be in parallel. I'm not entirely sure. But we can totally see all of our lines here. I can beep out probably to any of these. And, oh, wait, right there. 26.8 normally closed. So that is definitely our 48 volt line. So in theory then, let's look at this chain here. We're going to verify that all of these connections are present on this chain. So I am going to switch back to the desk here. And I am going to then reattach to our 26 here. And we are first going to start off with 2610 common. And that was, there we go. Oh, it's way the heck down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our 10. Okay. Our 26.9. Well, we already mentioned that one, so it's right there. There's our 26.8. 14.1 common. So that'll be here. Aha! Let me verify something here, because I think we caught it. No, it doesn't show a relay contacts here. Back over to the other one here. Yes, so we should be looking for a pin in socket 1 here in the upper right. And we said 14.1 common. Oh, you can't see this. There we go. So 14.1. And there's nothing in 14.1. So there it is right there. That's our break. And 9.3. 1, 2, 3. Which is again going to 14.1. So there's our break right there. It's supposed to go into that spot right there. All right. So I will push that in there. There you go. So now from 26, I should have a chain to 9.3. 1, 2, and there we go. Okay, we got it. And from 9.3, we should go 7.6. So 1, 2, 3, 4, 5, and there we go. And 16.2. And where is that hiding? There we go. There we go. All right, so that is it. We got both of our wires. They're back in place. I'm just going to leave those there because they've caused us grief in the past. And if anything is wrong, I will know exactly what I have to do to fix that. But there, a little bit of simple wiring. It wasn't as simple to track down the relay points as I thought they were. But now that I figure how to do point-to-point on this and how the point-to-point works, we've managed to sort out all the wires. The next challenge on this here is going to be the relays. And that is going to be a fun challenge. But it is late. I have other things I need to do tonight. And I hope this video is ready by tomorrow morning. And I hope you enjoyed watching this, and I hope you've learned a little bit about how the wiring on these IBM relay panels worked. And until next time, have a good one.